Okay, Year 12. This video is all going to be about the production of alcohols. So there's our syllabus point in yellow, top left. Investigate the production of alcohols, including one we've just learnt about, substitution of halogenated organic compounds, and also fermentation. And I think I added another one into there too. Here, it's on the first page. So we already know that we can make an alcohol by the addition reaction between an alkene or an alkyne and water. Okay, so here in my example I've got ethene, and ethene, we're adding water across the double bond. Remember that we need dilute sulfuric acid to do this, and then we're getting an alcohol group and that new hydrogen added across there. So we're going down to an alkane backbone, so we're producing an alkanol. So ethene, water, making ethanol. So that's one way we can make an alcohol, is taking unsaturated and adding water across it. Okay, the second one is, we just learnt about the opposite of this one. So we can do a substitution reaction with a halogenated alkane, and we can swap out the halogen, I was meant to draw a curve there, and we can add on the OH from a water. Okay, so here I've got 2-bromopropane. It's written just below there. That's good. I got it right. And I'm substituting it with water, and so it's becoming an alcohol group on the 2 position as opposed to a bromine. So it's becoming propan-2-ol, and what's left over is the bromine now bonds with a hydrogen to be hydrogen bromide. Okay, as I say here, this occurs because the bond energy between carbon and the halogen is fairly weak. The reverse reaction is slightly spontaneous, so you will need a catalyst to do it. And it's a familiar one. It's that dilute H2SO4 that we use in the previous one too, the addition of water across there. So that helps with memorizing that catalyst. Alright, so there's another way we can make an alcohol. And this third way, we're going to go much more in depth. It's a new way than all the others, and it's that fermentation. So alcohol is produced by fermentation of sugars, okay? This is the most common way we make alcohols. So fermentation is the process where sugars are reacted and they form alcohols, and it happens in anaerobic conditions or anaerobic environments. And anaerobic means lack of oxygen, okay? There's a reason for that. We'll get onto it soon. Now, to do this, you need yeast, which is a single-celled fungus. And that yeast converts the glucose, that sugar, to ethanol in anaerobic conditions. Okay? First observed in nature. Okay? Some fruits will ferment when fallen on the ground and start to rot, especially that underside. If it's lacking exposure to air, it'll start to ferment as well. Okay? So first observed in nature. So we're guessing, because humans have been doing this for a very long time, that we first observed it very, very early. I think I mentioned down below that animals seek out these fermented fruits and fermented things too. So anaerobic, if oxygen gets into the system, what ends up happening is, instead of that alcohol becomes oxidized. Alcohols becoming oxidized become ketones, aldehydes, and carboxylic acids. So if we're talking about ethanol, when we're wanting to produce ethanol, primary alcohol, that fully oxidized is going to be ethanoic acid, which is how originally vinegar was made. It was made unintentionally. It was made unintentionally because their vessels happened to be exposed to oxygen. They cracked it open thinking it would be full of wine, and they got that vinegar smell. So vinegar was an undesirable byproduct. These days our systems are really good though, and so we have to actually purposely make vinegar for our needs. Yeah, Here we go. Humans have learnt the chemistry of producing ethanol to a fine degree. The agricultural revolution at the start of civilization may have been because of a guaranteed source of food, but also alongside what's happening is a guaranteed source of these sugars to make alcohol. So you can see some arguments from some historians and stuff saying that, while food was important, humans also placed a great importance on fermentation as well. Now, right down the bottom, we've got this big formula. I put it nice and big and bold. It's one that you're going to have to be able to produce it in exam. I was going to say remember, but not quite. You need to produce this during the HSC exam. Now, what we have on the left-hand side is sucrose, or am I going to say glucose? I forget the two. I think it's glucose. Okay, C6H12O6. How I remember is the sixes, I kind of remember, and the H12O6, you see that's in the same ratio as H2O, 2 to 1 there. Carbohydrates have carbon, hydrogen, and oxygen, and the hydrogen and oxygen are in the same ratio as water. Okay, so I just go in there and remember it's O6 and C6. It must be H12 to keep that same ratio. Okay, the product that we're aiming for is this one here, C2H5OH. We're hoping for ethanol, okay? And the byproduct of this process is carbon dioxide. Okay, so it's a gas that's going to bubble out of there over time. Do I mention it down here earlier? I might talk about it now. So these vessels that it needs to be done in need to be sealed against oxygen but able to let out carbon dioxide. Okay, so we can't let oxygen in, but we need, through this, that's probably why it's got this funny thing there, prevents oxygen getting in but allows out some CO2. Otherwise, if you don't let the CO2 vent, you get big explosion. Okay, very bad while fermenting. Fermentation vessels, glass, metal and stuff, you don't want shrapnel. Alright, look at those ancient Egyptians making alcohol. Okay, any source of sugar can be fermented. Oh, here I go about animals. So chimpanzees and other primates have been observed seeking fruit that is rotting and fermenting. Other animals have been observed selecting fermenting fruit, such as bats, corvids, which are crows, what's the other word that I'm looking for? Ravens and magpies and stuff like that, and other mammals as well. Primates, do I mention? Yeah, primates. I think I remember some people talking about, oh look, I've got a picture there, a very drunk moose. We shouldn't laugh, but a drunk moose stuck in a tree. So animals are seeking these out. It's no wonder humans are seeking them out too. Fermentation of sugars from nature can be classified into 3 groups. I put a nice table here for you. This might be going a little bit beyond the syllabus, but that's okay. We've got beers, which are fermenting starches, okay? So from hops, which is normal traditional beer, you've got sorghum, wheat, oats and malt, and rice as well, okay? So grain beers can be fermented, those sugars from them. You've also got fruit and vegetable fermentation, which we call wines generally. So they're the fermentation of fructose and sucrose, so different sugars there. So we get cider from apples, perry from pears, wine, traditional wine from grapes, and rum from sugarcane. And then you've got some other sources for sugars as well. You may have heard of mead, which is made from honey. And you also get, sometimes popular in Asia more, fermented milks from domesticated mammals. Okay? So you get alcoholic milk beverages. Carbohydrate sugars always have the form, this is what I was talking about, CXH2NON, so that 2 to 1 ratio. It'll help you remember the formula, okay, of glucose. So,
Delivery.